Hello there guys. This presentation focuses on how to configure the DHCP Relay functionality on Huawei's enterprise network simulation platform. Here's the architecture we're going to be working with to show you what the DHCP Relay is. But before we do this, let's go ahead and demonstrate how DHCP works and why we need DHCP on a network. So here is the standard architecture to demonstrate the DHCP functionality. We have here the router AR2220 running the DHCP server process at the moment. And then we have two computers. The first one, we're going to manually configure this device. And then we're also going to enable the DHCP on this device to show you how easy it is to configure devices using DHCP. So for every host on a network to participate in network layer communication, it requires an IP address. This IP address, first of all, serves as a unique identifier for the host. And second, the IP address more like describes the location of this host within the network. Because the IP address, as we know, has two components. The first component is the network ID, and the second component is the host ID. So before the DHCP method of configuring host on the network, we usually have scenarios where hosts are configured using the manual configuration method. So let's go ahead and demonstrate that. Assuming we want this PC to have some IP address parameters on the network, this is how we're going to do it. We first of all, do the static configuration, and now we're going to manually assign the IP address 10.1.1.1 to the host, and then we give the subnet mask of 255.255.255.0. And for the gateway currently on this router is 10.1.1.254. So part of the configurations we can also do for the manual part for the host is the DNS server address. So 8.8.8.8, and then for the second DNS server, in case the first DNS server cannot be reached, 4.2.2.2 is a very popular one. So we're only performing the IP version 4 configurations on this host, and we hit apply. Let's go ahead and check the configuration on the device, IP config. Now, these are the parameters that we have configured: the IP address, the subnet mask, the gateway, and then we have the DNS server addresses that we have configured on this host. You would agree with me that when the number of devices on this network scales up, for example, you have about 100 or 200 hosts on the network, this could be really difficult to configure the systems one by one. And not to mention, it's going to be really hard for you to manage all the IP addresses manually. Like, for example, if a host leaves the network, or imagine scenarios where you have mobile devices, that would even be much of a difficult thing to manage. So this is why we have the DHCP. For the DHCP, we just need to select the DHCP configuration option and obtain the DNS server address automatically, and then we apply. At the moment, there is a DHCP server process running on this router, so this host should obtain the IP address directly from the server. So let's go ahead and IP config. Exactly. Now we have the IP version 4 address of 10.1.1.252, and then the subnet mask, the gateway, and the DNS server address, like we have for the manually configured client. So this is the advantage that DHCP offers you. You get to configure hosts very easily. Imagine when you have 100 devices, you just need to enable the DHCP process and all the devices can get the IP address. So one major difference between manually configuring clients and using the DHCP process is when you manually configure a client, you are going to perform the configurations repeatedly for each of the hosts that need the IP address, the gateway, and all other configuration parameters. But when you use the DHCP, you only configure once on the DHCP server. You define your pool, the IP addresses to offer, the gateway IP addresses to deliver, and as well as the DNS server addresses. And there are a host of other configuration options that are also available on the DHCP. And then for the clients, you only need to enable the DHCP process, and that's it. You get the IP address configurations. So configure once and use many times. How this process of the DHCP works is that we're going to look at this very basic scenario. DHCP works as a client-server technology. Like we've seen, this is the server, and then each device that requests the DHCP services are the DHCP clients. So it's a technology that is designed for the dynamic allocation of network parameters, such as the IP addresses, the gateway, the DNS server, etc., to devices on a network. So the way the DHCP works is we have the client. First of all, when you start the process, the client is going to send what is called a DHCP discover message. But because it does not have an IP address and it does not know what the DHCP server IP address is, I mean, this device just basically started, right? So it doesn't have any of this information. So it needs to flood this message on the network to discover any active DHCP servers as a broadcast. And then when there's a DHCP server, the DHCP server is going to send a DHCP offer packet as a unicast message. So some devices on the network, like the clients, some clients, due to the old software or the capabilities limitation, cannot support receiving unicast messages, unicast DHCP messages, because at this point, the client still does not have an IP address. The client will go ahead and at the time they send the DHCP discover message, there is a flag in the DHCP header called the broadcast flag. They need to turn it on. And once they do that, the offer message that will be sent from the server will be sent as a broadcast. However, if this is not the case, the DHCP offer message is sent as a unicast for most devices and most applications. And then after the DHCP offer is sent to the DHCP client, then the DHCP client sends a DHCP request, asking the server for the IP address and all the other network configuration parameters. And then finally, the DHCP server sends the DHCP acknowledgement. So now, one thing we need to observe here is a client will send a broadcast for the DHCP discover message as well as for the DHCP request message. In some scenarios where the DHCP server is not on this network, this could be a problem, such as when the DHCP server is deployed on another network. Broadcasts, as we know, cannot be forwarded across networks. So when the DHCP client sends a broadcast, the main condition for the DHCP server to respond to this broadcast is that the interface on which this DHCP process is running needs to be on the same network segment where this broadcast happens. So now we have the basics of the DHCP and how it works. Let's go ahead and look at our configuration topology here. What we have here, the difference between this topology and the previous one, like we've seen, is that instead of having the DHCP server on the same network as the DHCP client, we now have the server on a separate network segment. So here is the segment 192.168.1.0, and then here's another segment 192.168.12.0 running between the DHCP relay router here and the DHCP server. So what happens is if the DHCP client sends the discover message, this discover message is going to be flooded on this broadcast domain. And since our DHCP server is no longer running here, this could be a problem because the server will never be able to respond to this DHCP discover message or even the DHCP request message that the client is going to send. So this is why we need a scenario such as the DHCP relay. So the DHCP relay is going to act as an intermediary device between the DHCP client and the DHCP server. So whenever the DHCP client sends any broadcast packet, it is going to be received on a DHCP relay enabled interface, and then the DHCP relay in turn will forward that message to the server. So in terms of the communication, whether broadcast or unicast, the communication between the DHCP client and the DHCP relay is as if the DHCP server is on the same network segment. So what that means is the DHCP discover message is sent as a broadcast, and then the DHCP relay sends the DHCP offer packet to the DHCP client in unicast mode. And then the DHCP client sends the DHCP request message in broadcast mode, and then the DHCP relay sends the DHCP acknowledgement packet in unicast mode. However, the communication between the DHCP relay and the DHCP server is unicast all through. So whenever there's a broadcast or unicast received from the client, the relay will always send a unicast packet to the server. And it doesn't matter where the server is located really. The server does not need to be directly connected to the relay. Even though there are multiple networks between the relay and the server, the most important thing is there has to be a reachable route to the DHCP server from the DHCP relay, and there also has to be a reachable route from the DHCP server back to the DHCP relay. Now that we have this basic knowledge, let's go ahead and perform the configuration. The first thing is there is some set of configuration that we need to perform on the server, on the relay, and on the client. On the client, we only need to enable the DHCP process as we have seen in the previous demonstration. So let's go ahead and start the topology. So I will highlight all the devices I want to start and then click Start Device. So this is going to take a while. So at the moment we have all the PCs and the switch is started. There is no configuration on the switch at the moment. We're only going to leave it in its default mode. That is, all the devices will belong to the same broadcast domain. There's no VLAN related configurations here as well. Okay, now all the devices have fully started. So for the DHCP server, which is R2 in this case, let's go to the device. So to perform the first step, configure the global pool and start the DHCP process. To do this, we first of all go to the system view, and then we configure the global pool using the command IP pool, and then we set the name of the pool, right? So the name of the pool, we call it DHCP, just DHCP, and then we enter. So now we have created the pool and we're currently in the pool configuration view. For the pool, we're going to configure the range of IP addresses that we want to assign to host on this network here. So we do that by performing this step, network 192.168.1.0, and then mask 24. That's the first thing. And then the second thing we want to do is to configure the gateway IP address. So that command is gateway list. Remember, we're still in the IP pool view. So gateway list 192.168.1.254. That would be the gateway of devices residing on this network segment. So that's it. And then we want to also configure the DNS list as 8.8.8.8 or 4.2.2.2. Right. So let's display this to see the configurations we have currently. So we have the network configuration. This defines the pool, the pool where the IP addresses are going to be given from. And then we also have other configuration parameters such as the DNS list and the gateway IP address that we want to assign to host on that network. Now we have configured the pool. So let's go ahead and quit the pool view. So, and start the DHCP process. So we do that as well from the system view, DHCP enable. Now the DHCP process has started. So remember, if we go ahead and enable the DHCP on the client, we cannot be able to get any configuration information, ipconfig. Let's wait a few seconds. We won't get any IP address configuration. At the moment, the client is already broadcasting the DHCP discover message, but it cannot get to the router because the DHCP process is running here at the moment. So now we finish step one, configure the global pool and start the DHCP process. That is done. The second is configure the interface for receiving DHCP messages from the client or relay. So we need to configure the interface for receiving the DHCP messages sent by the client or the relay in this case. So let's go ahead and do that. So the interface receiving the message would be the gigabit Ethernet 0/0/2. So let's go there. Interface gigabit Ethernet 0/0/2. Right, display this. So currently there's no IP address configured. So we're going to configure the IP address from this range for the interface. So IP address 192.168.12.2. So we use .2 to represent the router 2, right? .2, and then the subnet mask of 24. So that's it. We configured the interface, right? And now the interface is up. So the next thing we're going to do is configure the interface for receiving DHCP messages. So we have configured the IP address on the interface, but we haven't enabled the DHCP process on this interface. It's only enabled on the device, on the router at the moment. So let's go ahead and do that. So to do this, DHCP select global, because we configured a pool. So we use the DHCP select global, and then we enter. Display this to see the configurations we have running at the moment. So that's it for this router. Now the next thing is ensure the DHCP server has a reachable route to the DHCP relay. So in this case, the DHCP relay, although it's router 1, but the DHCP relay process will run on Gigabit Ethernet 0/0/1 of router 1. So we need to have a reachable route from this router to this interface, which resides on this network segment. So what we're going to do to achieve that step is quit. First of all, we configure a static route pointing to this broadcast domain. So let's go ahead and do that using the command IP route static 192.168.1.0.24 should use the next hop of 192.168.12.1 for router 1. So what this means is if this router 2 wants to go to this network, which is here, it should send the packet to router 1 on this interface 192.168.12.1, which we're going to configure as the IP address on this interface. So this will serve as the next hop to go to this network. So that's it for the configuration on the DHCP server. So the second thing is for the DHCP relay. The DHCP relay is router 1, so we go to the DHCP relay. So for the DHCP relay, the process is, okay, start the DHCP process, system, and then to start the DHCP process, as usual, we use a command DHCP enable. And now we're done with step 1. Let's go to step 2. Configure the relay interface and specify the IP address of the DHCP server. So now, before we configure the DHCP relay interface, let's configure the interface Gigabit Ethernet 0/0/2 pointing to router 2. So we go to the interface Gigabit Ethernet 0/0/2, and then we put the IP address 192.168.12.1 in this case, and 24. Right, now we're done with that. So we go to interface Gigabit Ethernet 0/0/1, and then we enter the IP address, which will now be the gateway IP address 192.168.1.254, and then 24. So that's it. We have configured the two interfaces, but this interface will be the relay interface. We cannot specify this interface because the broadcasts are going to be flooded on this segment. So now let's display this. So this is the current configuration that we have. There is nothing to show that this is a relay interface. So how we do that is to configure DHCP select relay on this interface, and then DHCP relay server IP, and then we specify the IP address of the DHCP server. So we know the DHCP server process is running on the port interface gig 002. Display this. So this DHCP server process is running on this interface, so we need to specify this IP address as the DHCP server IP address. So we'll go back to the relay, and then the server IP is 192.168.12.2. That's it. And then let's go ahead and display this. So this is what we have at the moment. We've enabled the DHCP relay functionality on this interface, and then we also configured the server IP address 192.168.12.2, which is the IP address on Gigabit 0/0/2 interface of the router 2. And the third step is to ensure that the DHCP server has a reachable route to the DHCP relay. So at the moment, the relay can already reach the DHCP server because this is the directly connected route. Now, let's go to the DHCP client. Let's see if we now have the IP address. Right. Now we have the IP address. 192.168.1.253, pointing to the gateway 192.168.1.254, and the DNS server address of 8.8.8.8 or 4.2.2.2, as we have seen in our IP pool. So display IP pool. When we display IP pool, we see at the moment we have a pool name DHCP, what we configured before. The used IP addresses is 1. The total number of IP addresses is 253. And the idle or the unused IP addresses are 252 because we already assigned one IP address to the DHCP client, the PC2. Now let's go ahead and also confirm display IP pool name DHCP used. So this is going to show the list of used IP addresses on the network. So as we have here, this is a more detailed display of what we have configured. This is the network segment that we've assigned. So the index of 252, we assigned the IP address 192.168.1.253. The MAC address of the device that we assigned to is 5489 and 1D9. So let's go ahead and confirm that. Yeah, so that's the MAC address of our DHCP client. So 5489 and ends with 1D9. So this is all we have for the DHCP configuration, how to configure the DHCP relay. As we can see here, this is the table. We have first of all the index 252. We have the IP address, which is assigned to PC2. We also have the MAC address of PC2 and the lease. So this is actually counting upwards. This is at the moment 200 seconds. And this IP address is going to be valid for as long as 1 day. So that's how long this client can utilize this IP address, or even renew the IP address before the expiry. So let's go ahead and see for PC1. At the moment, IP config, there's no IP address. So we do the same thing. DHCP apply, and then wait for a few seconds. And then we can check again. Right. So we have also the IP address. So these IP addresses are assigned in decreasing order from 253 down to .1, for the IP address ranges that we've configured. And that's how easy it is to configure the DHCP relay on the Huawei's ENSP platform. If you have any questions, please you can leave in the comment section, and I will see you in the next one.